Welcome to Anatomy and Physiology, Chapter 2. This chapter is going to be over atoms, ions, and molecules. This is going to be pretty much a refresher for you for any chemistry class you've ever taken. But it might have been a couple of years, so we'll get freshened up on what all of these terms mean and how it correlates to the rest of anatomy. One might think with human anatomy that we would start off with the entire human. But we're going to go ahead and lay a really good foundation, especially for those of us who have been out of chemistry for a couple of years, by going down from the organ system level, below the organ, taking it to the tissue, the cells, to the organelles, to the chemical level, and finally all the way back to the atoms and the molecules. Let's go over some terms first. Matter is a substance that has mass and occupies space. An atom is the smallest particle that exhibits the chemical properties of an element. We have the periodic table of elements, neatly organizes all of those elements based on their weight. The lightest and the smallest is hydrogen. Then we have a helium atom. We jump from 3, 4 to carbon atoms, nitrogen atoms, oxygen atoms, and we build ourselves all the way up into a little bit of the strange ones that they're still coming up with. But all of the elements are organized in this form. So everything here is an atom. The periodic table of elements is going to show us a couple of different facts about each atom. First off, it tells us the atomic number. The atomic number is the number of protons that the atom has. The element symbol is a letter used to represent that atom, so hydrogen is an H, whereas potassium is a K. The atomic mass number is this number underneath. This represents the mass of the protons and the neutrons, the heaviness of the atom. You'll notice the lightest atom is hydrogen at 1.008, and as we go down, we gain more protons. Lithium has 3, and it's gotten heavier. Sodium has 11, it's up to 22. Potassium has 19 protons, and its weight is up to 39. So as you go down, they get heavier. Also, as you go from left to right, you can see they're also gaining in weight. Have you ever heard that you are, in some cases, 50% water? Well, it seems a little strange. I mean, you're not just a water balloon walking around. You have rigid structures, you have tissues, you have bones. What does that mean? This picture shows us the actual percentages of water in the body of different sexes and ages. Infants are the real water balloons. They are 75% water. Children are around 65. An adult female is around 55% water, and an adult male is 60%. I mean, using this calculation, you can now say that in reality, you really don't weigh that much. It's mostly water weight. Let's see how that is. This chart shows the most common elements of the human body. The major elements are those that collectively compose more than 98% of body weight. Oxygen composes about 65% of your body weight, followed by carbon at around 18% and hydrogen around 10%. Now we know that water is composed of 2 hydrogen atoms to 1 oxygen atom. So when you add those two together, you can kind of see how that 55 or 65% body weight comes around. We have a little bit of nitrogen, 3%, some calcium, and some phosphorus. Our minor elements collectively compose less than 1% of our body weight. These include sulfur, potassium, sodium, chlorine, magnesium, and iron. Very small percentages, but all of these are going to be essential to the body functioning properly. Just as a tip, when it comes to the exam, I typically throw one question about this table in there. It could say, which of the following is a major element? Then it would list off sulfur, potassium, nitrogen, and sodium. Could you know that nitrogen was a major element? Just kind of gives you an idea of what that exam question could look like. Moving on to components of an atom. Atoms are composed of three subatomic particles. We use the word subatomic to say that it's below the atom level. These are the things that make up an atom. They include they include neutrons, protons, and electrons. If you recall, an atom was the smallest, going back here, an atom is the smallest particle that exhibits the chemical properties of an element. When we come to the neutrons, the protons, and electrons, these compose every single atom. So a carbon atom has neutrons, protons, and electrons, the same way a hydrogen atom has neutrons, protons, and electrons. The only thing that varies is the number that they have. This is true for all of the atoms. Neutrons and protons are both located inside the nucleus of the atom. This nucleus is going to give you the weight of that atom. If you have 8 protons and 8 neutrons, that means our weight is going to be somewhere around 16. Around the nucleus, we will find the electron cloud or shells. It's here that the electrons are going to be circulating at very fast speeds around the nucleus. And as you add more electrons, you start off with an inner ring of 2 electrons. Then whenever a third electron comes around, it starts the next ring, which fills up with a total of 8. After which point, if a 9th electron comes, it'll form a new ring, and then you'll have a third one. And it just keeps building like this. Your outermost ring is where all of the bonding happens in chemicals. So in chemistry, we care a lot about what is happening in that outermost shell. Another important factor when it comes to bonding is, does an atom have a positive or a neutral charge? Inside of the nucleus, all of our protons are going to have a positive charge. This example has 8 protons in it, so it would have a +8 charge. The neutrons have no charge. They are neutral, so they don't negate at all the positive protons. The electrons, on the other hand, all have a negative charge. With atoms, you're supposed to find, there are some exceptions, but typically you find the equal number of protons and electrons. So they balance each other out with 8 positive charges and 8 negative charges. That gives us nothing. It's a neutral atom. And we're going to find out that sometimes we can take one of those electrons away and give our atom a positive charge, or maybe we give it an extra electron and give it a negative charge. We don't change the number of protons. Those are always the same, but we can change the number of electrons on the outer shells.